What I would like to talk about today are some of the common errors that I see from students as they're trying to solve equations using square roots. Now, to begin with, I want to talk about the third and final format of a quadratic expression, and that's called vertex form. It's sort of splitting the difference between standard form, where you have three things added together, and factored form, where you have three things multiplied together. A quadratic expression is written in vertex form if it is written in the form y equals, okay, here's our friendly neighborhood leading coefficient, a. And the number a is the same no matter what form you're dealing with. Now, it starts to look, after that point, a little bit like factored form does. A is getting multiplied by x minus h, where h is some number. But here's the big difference. X minus h is squared. This entire quantity is squared. And then I am allowed some other number to be added in the back. So across, I would say, between factored form a times factor and standard form a times thing plus thing plus thing. All right. Now, if you're going to solve an equation using square roots, just a warning. You need to make sure that the equation that you're solving is in vertex form. Must be in vertex form. In other words, all your x's must be inside of squared quantities. You're not allowed any x's outside of quantity squared. Only numbers can live outside here. So for example, let's take this equation. 3x squared plus 5x plus 1 equals 0. First of all, stop and ask yourself, what form is this left-hand side in? This left-hand side is in standard form. Number times x squared plus number times x plus number. Because it's in standard form and not in vertex form, because there is this x here in the second position, which is not inside of a squared quantity, this equation cannot be solved using square roots. It could only be solved if all the x's were inside of squared quantities. Now, the major reason for that is because square roots behave so poorly with plus and with minus. So let's take, for example, this equation, x squared plus 25 equals 81. Can this equation, first of all, ask yourself, could this equation be solved using square roots at all? What form is this equation in on the left-hand side? Now, this equation actually appears to be in two forms at the same time. On the one hand, it's in standard form because it's written as number times x squared plus number times x plus number. It's just that the number times x, the b value, is 0, and that's why we don't see that term. But simultaneously, this expression is also in vertex form because you don't see any x's which are outside of squared quantities. The only x we have is being squared. Okay, so yes, we can solve this equation using square roots. But can we use the square root and deploy it right now? Or do we have some preparation to do before we can unleash the square root on this problem? Now, very frequently, one of the most common errors I'll see in this section is trying to take the square root of the left-hand side term by term. Square root of x squared, and separate from that, the square root of 25. If only, I would love to be able to do this. It would be so convenient because look how quickly this would simplify. X squared, square rooted, the square and square root would cancel, and I would have just x. Square root of 25 would be just 5. Square root of 81 would be just 9. This would be lovely if I could do this. But if I check this quote-unquote answer in the original equation and check and see, is 4 squared plus 25, is that really 81? The answer is definitely no. The left-hand side is way too small. So this method of solving is invalid. It won't actually get us solutions to the original equation. We have to be very careful when we're solving by square roots before using square roots. You must isolate the squared quantity. You have to get x squared all by itself before doing anything else, so that you actually are getting a solution to your original equation.